This test review will cover the following topics: piecewise functions, polynomial inequalities, optimization, as well as combining functions. While this review does not cover every single question, hopefully it provides enough so that you'll see the overall pattern of how these questions should be answered or may be answered. Concerning the ones that weren't answered, all of the questions have answers that are posted through Schoology. Just make sure that you do the test 2 review assignment and it will show all the answers once you're done. In this example, we're asked to multiply the two functions f, which is square root of x plus 9, and g, which is absolute value of x minus 3. When we multiply them, we're going to basically put them next to each other. So square root of x plus 9 times absolute value of x minus 3. Because they're all grouped under a different operation, we can't actually finish the multiplication. So we're going to leave it like how it is. So this is the answer for strictly just multiplying the function f times g. But we're also asked to find the domain here. To find the domain, we have to look at each function individually and find what's called the most restrictive domain. Let's take the absolute value first. So when we think about the absolute value, it's asking how far is a number from 0. So normally absolute value of x. Of course, we can put any number that we want to. So let's say that we put absolute value of -5. What are we asking? We're asking how far is -5 from 0? So -5 is 5 spaces from 0. So absolute value of -5 is +5. We could put any negative number in here. I just chose 5 just to demonstrate what would happen. So let's say that we put 0. How far is 0 from 0? 0 spaces. Or similarly, if it were absolute value of 5, again, that's going to be 5 spaces from there as well. So it looks like for the absolute value function, we can put a negative number in, we can put a positive number in, we could put 0 in, and the function will still work. So what does that say about the domain? Well, the domain starts at -infinity because we can put any negative number that we want to in there. We can continue going and we will never find a number that will not work. So all the numbers will work. So if we go from -infinity to +infinity, that represents the entire domain of the absolute value function. But if we take the square root function, what we have here, what kind of numbers can't we put or shouldn't we put under a square root? Well, we shouldn't have a negative number under here. So what has to go under here should be a positive number. For example, square root of 36 is 6 because 6 times 6 is 36. But square root of -36, you can't really do that. We have to actually come up with a different kind of notation to express that. There is no number times itself that's going to give you a negative number. So what that means is that, again, what we have under the square root has to be a positive number. So if we have square root of x plus 9, then that means that x plus 9 has to be a positive number. In other words, it's greater than 0. If we subtract 9 from both sides, then what we're saying is that x has to be greater than -9. So think about that on a number line. Here's -9. The numbers greater than -9 are on this side. So basically, if we were to write the domain in interval notation, it means that we're starting at -9 and we can keep going to infinity and all of those numbers will work. Of course, -9 will work because if we put -9 in for x, then it's going to be -9 plus 9, which is 0, and the square root of 0 is 0. So -9 will also work. So this is our domain. So if we go back and look at our answer choices here, we'll notice that C is our best choice. So technically on this particular question, -9 should also be included. So this is actually written a little incorrectly. It should have been a bracket here. On this function, similarly, we're going to find the quotient. So we're going to divide the two functions. It says put the function f over the function g. F is 4x plus 5. So we're going to put 4x plus 5 on top. G is 2x minus 1. So that's going to go on the bottom. So we know that based on how everything is written here, B makes no sense and C makes no sense. And the only difference between the other two is basically the domain. So this one says that x can't be 1/2, and this one says that x can't be -5/4. So how could we figure this out? Well, think about a fraction. It's okay to have 0 over 5, and I'm just using 5 as an example. It could be any number. 0 over any number is going to give us 0. But what if we reversed it? If we had a number divided by 0, is that possible? Well, when we have this, our calculator is going to give us an error, and we need to know that this basically means that this operation is undefined, so it does not make sense. So what we want is, we want to make sure that we don't get 0 in the denominator. So in other words, in this case, our 2x minus 1 cannot equal 0. In other words, if we added 1 to both sides, then 2x cannot equal 1. Or if we divided both sides by 2, then x cannot be 1/2. So that tells us that the domain has to exclude 1/2. So the domain will not include 1/2. So to answer this question, the first thing that we need to do is to represent what's going on here. So this individual has a rectangular garden. So we're going to draw a rectangle. For this rectangular garden, they say that the width is x. So that's x. So if this side is x, then so is this one. We don't know what this other side is, so we'll call it y. So it says that the farmer has 1,200 yards of fencing. So if we add up all the sides, x plus x plus y, that it also has to add up to 1,200 yards. So basically 2x plus 2y is going to equal to 1,200. If we simplify this by dividing everything by 2, then we end up with x plus y has to equal 600. The other thing they mention is they want us to express the area of the rectangle. So how would we do that? Well, the area of that rectangle, of this rectangle here, is going to be x times y. So we could leave it like that, but we want to express everything in terms of one variable. So what do we know that can help us? Well, we know this. We know x plus y is equal to 600. And if we do some work with that, we could actually solve for a variable. So we could actually solve this for for y, by subtracting x from both sides. So we end up with y equals -x plus 600. So if y equals -x plus 600, that means that we can replace y with -x plus 600. So we're going to do x times -x plus 600. We're going to do the distributive property, and so we end up with -x squared plus 600x. But the thing is that it looks like there are two answers that have that, so we need to kind of work on the domain. So what is it that we know about sides? Well, we know that sides cannot have negative measures. So if this side is x, that means that x has to be greater than 0. Similarly, for this side, which we figured out is the same as saying negative x plus 600, because that's the y value, that side also has to be greater than 0. So we can say negative x plus 600 is greater than 0. If we got x by itself, let's say we added x to both sides, then what we're saying is that 600 is greater than x. Or another way of saying it is x is less than 600. X is smaller than 600. So what we're saying now is not only does x have to be greater than 0, but it also has to be less than 600. So that means that our final answer is A. If you are asked to either add or subtract numbers, we know that the following makes sense. A number minus another number gives us an answer. So if, for example, I put 3 here and I put 2 here, that's easy to work out. That's just going to be 1. Or if I put 2 here and negative 2 here, using your integer rules, this is just going to end up being 4. Of course, our integer rules say that these will just combine to give us addition. So we can add and subtract as long as we have two numbers. But what if all I gave you, or all you were given, was just 5? And I said subtract. Could you do it? No. We would only be able to do this and obtain an answer if we have two numbers. So we're going to use the same reasoning here. We're asked to subtract the functions f and g. So the function g is this one that I'm highlighting in green. And the function f is the one that I'm highlighting here in blue. So if we needed to subtract these two functions, we're going to subtract by going point by point. So notice when we get to 1, where x is 1, we have two values here that we can subtract. We can subtract 2 and negative 2. Notice that at that value, this point has a y value of 2, whereas this point has a y value of negative 2. Remember that what we had was f minus g. So f minus g. So f was in blue, if you recall. So for those 2 points, we would say 2 minus negative 2. Of course, 2 minus negative 2, we know is 4. So in other words, at 1, we end up with 4. So at 1, we end up with 4. We could do the same thing at our next point. So notice that when we get to 3, we have points that we can subtract. So 1 point, this one here for our function f is at 0, and the other point for our function g is at 1. So if we wrote this the right way, it would be 0 subtract 1, which means that we're going to end up with negative 1 as our answer. So in other words, at the x value 3, we end up with a negative 1 when we subtract it. So 3 negative 1 is here. So of course, we're going to connect these. And we can keep going point by point and getting the rest of them. But actually, this is enough for us to eliminate a few answer choices already. So A is clearly wrong because notice at 1, we have negative 2. B is also wrong because at 1, we have negative 4. C is a possibility because at 1, we have positive 4. So is D. At 1, we have positive 4. We know that at 3, we're supposed to have negative 1. So at 3, right here, we have negative 1. On D, at 3, we have a positive 1. So we know that's not right. Another reason why we know that D is not correct is because, remember, addition only or subtraction only makes sense if you have two numbers. And if you notice, when we get to 0, so let's clear some of this out. When we get to 0 right here, notice that we have a value for F, but we don't have anything here for G. So we cannot subtract at 0. So there will be no point at 0. So notice on this one, though, that we have a point at 0. Can't have that. Clearly, the next one at 0 has no point. So C is the correct answer. On this function, we're asked, given that this is an expression of f of g of x, what would f of x be and what would g of x be? So g of x is the inside function. So notice that the inside of what we have here is negative 7x minus 14. So we're going to say that g of x has to be negative 7x minus 14. Our function f of x is the outside function. If you notice on the outside, we're just raising it to the 7th power. So f of x is anything we input, raise it to the 7th power. So this one is going to end up being B. To answer this question, the first thing that we'll notice is that our fence has to be at 0. So we're going to put a border right here at 0. Then we have to decide what rule would go on each side. So this rule happens whenever x is less than 0. So that would be the left side. So that's negative x plus 2 on this side. The other rule happens when x is greater than or equal to 0. So that would be the right side. So radical x plus 3. So what we need to do now is to use either basically substituting points or some kind of transformation to graph the points. But one thing that we'll notice, though, is that this particular inequality has an or equal to. So that means that when we graph radical x plus 3, we have to put a solid point on the boundary. So let's say we put our boundary point. So our boundary is going to happen where x is 0. So if we input 0, then we have square root of 0 plus 3, and square root of 0 is 0, plus 3 is 3. That means our boundary point here would be a solid point at 3. If we put our other values in, so let's say we put a 1 in. So square root of 1 plus 3 is basically the same as 1 plus 3. So in other words, right here where x is 1, we're going to end up with a y value of 4. And if we keep substituting, basically what's going to happen is we're going to end up with a curve that grows gradually like we have here. For our other value, we know that since the inequality does not have a line under it, when we put the inequality, it's going to be an open circle. So if we substitute 0, the opposite of 0 plus 2 into our equation, the opposite of 0 is just 0. And so we end up with 2. So 0, 2, we would have an open circle. So remember, this is not a point right here. This is just something extra I have on here. But this is an open circle right here. and then we would also get the rest of the points. So we could substitute to do that, or we could just figure that the slope is -1. So the slope is -1. So that means that we can go up 1, left 1, put our point, up 1, left 1, put our point, and so forth. So this is what the rest of the graph is going to look like. To graph this function, what we need to do is to potentially think about the parent function. So the parent function here is this function. And what we're doing to it is we're adding 1. So when we're adding 1, we're taking the parent function and moving everything up 1. So what exactly does this parent function look like? Well, first of all, this intx sometimes is written this way. And to put it simply, it just basically says round whatever you have in there down. So as an example, if I had the floor function, which is what it's called, applied to 0.1, I'm going to have to round down. And so that would give me 0. Or similarly, floor function to 0.5, I round down, and that's going to give me 0. Or 0.7, I round down, and that's going to give me 0 also. But if I'm at an integer, like let's say I'm already at 0, and I said, what's the floor of that? It's exactly what it is. It's going to be 0. Or the floor of 1 is going to be 1. So let's think about what that would look like if we graphed it. So if we sketched a graph of that, let's say we started between 0 and 1. So at 0, so when x is 0, the floor function gives us 0. At 0.1, it also gives us 0. At 0.5, we still have 0. So basically, as long as we're between 0 and 1, we stay at 0. And we know for sure that this point is here, 0, 0. When we get to 1, the floor of 1 is 1. So the floor of 1 is 1. The floor of 1.1, we round down, is also 1. So basically what happens is for the next set of values, 1.1, 1.2, 1.3, they're all going to be at 1. So if we continue this pattern to the rest of the numbers, our floor function would basically give us something that looked like stairs. At the end of each step, we're going to put an open circle. And the reason for that is because a point can't be in two places at one time. So if I know for sure this point is here, then there's an empty spot down here. And if I know this point is here, there's an empty spot down here, and so forth. So if we took this floor function and did this to it, where we moved everything up 1, what exactly would that look like? Well, this first step, instead of being at 0, would be at 1. So our first step would be here. Our next step would be at 2. And we can keep going to make the rest of our graph and so on. We can even reverse it to get the other portion of our graph and so on. So this is basically what this graph looks like. If we wanted to solve this algebraically, the first thing that we need to find are the zeros. So where is this equal to 0? So for x plus 6, the first 0 that we would have is -6. For x plus 3, our 0 would be -3. For x plus 1, our 0 would be at a +1. We could then choose some test values. So to the left of negative 6, we might test to see negative 7. What would happen there? To the in between here, between negative 3 and negative 6, we could have negative 4. Between negative 3 and 1, 0. And to the right of 1, maybe 2. So if we input 7, it would be negative 7 plus 6 times negative 7 plus 3 times negative 7 plus 1. Negative 7 plus 6 is negative 1. Then negative 7 plus 3, that's negative 4. Negative 7 plus 1 is negative 6. If we multiply everything out, we end up with a negative 24. So basically, if we input negative 7, we end up with a negative number. If we tried the other ones, negative 4 plus 6 would give us 2. Negative 4 plus 3 gives us negative 1. Negative 4 plus 1 gives us negative 3. And if we multiply that, we end up with a positive 6. So if we tried the rest of these, what we'd end up with is a positive if we input 0, and also a positive if we input 2. But what we're asked for here is, when is this less than 0? In other words, this is like saying, when is it negative? So it's only negative right here. So basically, between negative infinity and negative 6, so starting from out here at negative infinity and continuing along until we get to negative 6, this is going to be our answer. That's where we have negative values for the given function. Actually, I just realized I made a mistake. This should have been a negative 1, in which case our test value would have been a negative 2. So let's redo this part. So if we input a negative 2, it turns out that we would have negative 2 plus 6 times negative 2 plus 3 times negative 2 plus 1. So this is going to be a positive 4, this is a positive 1, and that's a negative 1. So when we multiply this out, this gives us a negative 4, which means that on this interval, we actually end up with a negative answer. So it turns out that we also have between negative 3 and negative 1. So from what we had before, we know that we're going to have negative infinity to negative 6, but we also have the space between negative 3 and negative 1. So this is our answer. So the first thing that we would need to do here is to represent the situation. So when it describes a box, it's really talking about a prism. So let's see if we can draw a prism. And this looks terrible, but this is our prism. It says that the base is a square. So one side is x, the other side is x. So there's our square at the bottom. We don't know anything about the height, so we're going to say the height is y. It describes the volume as 341 cubic feet. Remember that volume is length times width times height. In this case, x times y. That's the same as saying x squared times y. So we know that the volume, x squared times y, is equal to 341. But what else do we know? We know that it mentions about square feet. And also it says something about the cost for each side based on the square feet. So square feet is an indication of area. So anytime you see square feet, square centimeters, or any such units, it reminds us that we're dealing with area. So what we need for this shape is the surface area. So for the bottom, the surface area would be x times x or x squared. For the top, it's also x squared. So we have 2x squared to represent both bases. We know also that for our side, here has one side of x and another side of y. So the area of just this side would be x times y. But of course, we have another side that's equivalent. So the front is also x times y. And we have two more faces that are exactly the same. So basically, we have 4xy if we're talking about the sides. So we need to add these, and this would represent our surface area. But what we're asked is not to express the surface area. Surface area is just a jumping point to express the cost. So our cost for the bases, for the two bases, for the top and the bottom, it says that the cost is $1.50 per square foot. So we have to multiply that $1.50 times our square feet. So it would be $1.50 times the bases. For the sides, it mentions that the cost there is $2 per square foot. So it'll be $2 times our square footage. So now let's simplify this. 2 times 1.5 is 3, so we have 3x squared. 2 times 4 is 8, so we have 8xy. We need to state that, first of all, this is the cost. So the cost is 3x squared plus 8xy. And we would be done, except that now we have an equation that has two variables. So we need to basically take this y and represent it some kind of way as an x. The other equation we have over here gives us information about how to do that. We know that x squared times y is equal to 341. But if we're trying to get y by itself, what will we have to do? Remember, how do you undo multiplication? You undo multiplication with division. So to get rid of that x squared that we're multiplying, we're going to divide by x squared. So if we divide this side, the x squared is gone, and now we know that y is the same as saying 341 over x squared. So where we have y, we can replace it with 341 over x squared. So our new cost equation is going to be 3x squared plus 8x times our y value, which we know is 341 over x squared. This 8x, we could put it over 1 and do our multiplication. So it turns out when we do that, we're going to end up with 3x squared plus 2,728x over x squared, because we're going to multiply numerator with numerator and denominator with denominator. For this portion of it, we can reduce that. Both the numerator and denominator are divisible by x. So if we divide them both by x, we're going to end up with 2,728 over x, and then we still have our 3x squared. So that is our new cost equation, and that's going to correspond to B. If we solve this inequality, let's say we solved it algebraically. If we solved it algebraically, then we could say that the roots would be -4, +1, and +2. And we can choose test values at -5, at 0, 1.5, and 3. Those are just some random numbers that are on those spaces between those numbers. So if we put -5 in, so -5 plus 4 times -5 minus 1 times -5 minus 2. So this is going to be -1 times -6 times -7, which is going to give us a -42, which means that on this interval where -5 is, we end up with negative values. If we input 0 the same way, we would end up with a positive answer. If we input 1.5 the same way, we would end up with a negative answer. And if we input 3, we'd end up with a positive answer. We could have gotten the same result from looking at the graph. If you notice that to the left of -4, we said that there was a negative value. So to the left of -4, you'll notice that what we have, everything is under the graph, so it's going to be negative. Between 4 and 1, between -4 and 1, so in this space right here, notice that everything is above the graph. So that means that we have positive values. Same thing here in this space between 1 and 2. Between 1 and 2, notice that it's under the graph, which is negative, and also to the right of 3. So to the right of 3, notice that it's up at the top. So we could have gotten the same sign chart just from looking at our graph. In terms of what our answer is, notice that it says f of x is greater than 0, so or positive, and that would be these two intervals. So basically, our answer has to be between -4 and 1 union 2 to infinity. So what we need to do here is to first find out what the zeros are. Notice that one of the zeros is at -3. We have another 0 at +3. And we have another 0 here at 5. What we would normally do is to list these zeros on a number line. So we know that we have a 0 at -3, we have a 0 at 3, and we have a 0 at 5. What we would like to tell is, or determine, is what happens on any part of this graph, whether we're going to have a positive or we're going to have a negative value. So let's say we looked at this section here that's to the left of -3. So if we look to the left of -3, what do we notice? Well, we notice that everything on that section is underneath the x-axis, meaning that we have negative function values. So basically to the left of -3, we have negative function values. So now let's test the next interval. The next interval is between -3 and 3. So between -3 and 3, what do we notice? All the function values are above the graph. In other words, they're all going to end up being positive. What do you think is going to happen between 3 and 5? So what do you think should happen between 3 and 5? Well, between 3 and 5, this interval that we have here, notice there's a small piece that's under the graph. So that means that we have negative function values for that section. To the right of 5, which is this section here, what do we notice happening? Well, we notice that on that section, all the function values are above the graph, which means that we have positive values on that section. When we go back to the original question, it was asking when are the function values less than 0? In other words, when is it negative? So that would be on this section and this section. So how would we write the interval? Well, we say this first interval here starts at -infinity and continues, and it's going to stop at -3. So our first interval would be -infinity to -3. The next interval is between 3 and 5. So we're going to say union the interval between 3 and 5. One thing that we want to notice though is that our inequality symbol has a less than or equal to. So this or equal to means that we're going to have a bracket on our numbers. So we're going to put a bracket actually on the 3 and negative 3, and also on the 5. And so this is going to be our answer. To answer this question, the first thing that we need to do is to look at what the outside function is. So here notice that the outside function is g. This outside function says that whatever you input, we basically need to take the square root of that. So if we were to input x, then we would have to take the square root of x. So that's what that says. Let's say that we were to follow what it says here, which is we're inputting an inside function. So the inside function here is f of x. In other words, on the inside, we're putting 1 over x minus 8. So if our inside function is f of x, that means we're inputting 1 over x minus 8. So this is our composed function.